That's right. Today we're going to celebrate your birthday because it'll happen sometime this year, and might as well have one video dedicated to your special day. So happy birthday from me. And while we're talking about your birthday, why don't we also talk about 4-1, 4-2, corresponding congruent parts, and ways to prove that triangles are congruent. Well, the first thing you're going to need to do is make sure you've grabbed a graphic organizer. It's going to go on the top half of your page. And we'll be going over example 1 and 2 using that graph paper. Make sure your daily agenda is in there also. So underneath your title, I'd like you to write the question, how many corresponding congruent parts can you find? Corresponding meaning in the same place, and congruent meaning equal. What you're going to do in our first example is you're going to plot 6 points, A, B, C, D, E, and F. Point A is -1, 2. Point B, 4, 2. Point C, 2, 4. Point D, 5, -1. Point E, 7, 1. And point F, 10, -1. I'd like you to pause the video, plot those 6 points, and then come back to me and we'll review what you need to look for. Okay, you should have plotted those points now. Let me go ahead and move this out of the way so you can see your 2 triangles. Hopefully this is what you have. And I'm going to move your birthday cake over here and zoom in on my 2 triangles. And note that we're going to be making a list of congruent sides and angles. So the first thing I notice is that this bottom length right here, AB, is 1, 2, 3, 4, 5 units long. And that's the same exact distance as DF is. Uh-oh, the cake's in the way. That means that AB is congruent to DF. I also noticed that the smallest side, CB, is congruent to the next smallest side, DE. CB is congruent to DE. Lastly, the long side over here, AC, which I'm going to mark with 3 hash marks, is congruent to the other. AC is congruent to EF. That's 3 sides, 3 corresponding congruent parts, only looking at sides. I'm going to change colors here and get prepared to now look at angles. Now what we're going to do is look for included angles. So by included angles, here's what I mean. In between the side with the hash mark of 1 and the hash mark of 3, the included angle would be angle A. Let's find the other one now. So we're looking in between 1 and 3. Here's 1, here's 3. The included angle there is angle F. That means angle A is congruent to angle F. Next, the included angle between 1 and 2 is B and D. That means angle B is congruent to angle D. The last angle is easy to find because it's the only one that's not been used. Angle C is congruent to angle E. Now that's 3 congruent sides, 3 congruent angles. That's 6 corresponding parts total. The last thing that I want you to be able to do is to tell me the names of the triangles that are congruent. And this is really important. I'm going to follow the hash marks of the sides from 1, 2 to 3 and name that triangle. So I'll call this triangle ABC. Triangle ABC is congruent to triangle. I'm going to have to follow the same path from 1 to 2 to 3. Will be FDE. Let's see that again. From 1, 2, 3. That's triangle FDE. FDE. The order of the points is very important because it shows that angle A is congruent to angle F, angle B to D, angle C to E. For your try, I'd like you to copy down the 6 points here and again plot those 6 points to reveal 2 triangles. After that, let me move my try out of the way. After that, you're going to find 3 sets of sides and 3 sets of angles that are congruent and then name the 2 triangles that are equal. So when I look at your notes, here's what I should see. at the very end, triangle something is congruent to triangle something. So you'll have 3 pairs of sides, 3 pairs of angles, and then tell me which triangles are congruent. Now, just in case you need a little bit of help, I'll go ahead and show you the three points plotted to reveal this triangle and this triangle. Good luck. Okay, in the bottom half of your notes now, I'd like you to write the subtitle, 3 ways you could prove triangles congruent. And why is it that we even want to prove that triangles are congruent? That's why I'd like you to copy this paragraph. Here's what it says. If you prove that 2 triangles are congruent, then you can say that all 6 corresponding sides and angles are congruent. So if you can show 2 triangles are congruent, then those corresponding sides and angles are all congruent. That's just like what we did in the examples above. I'm going to show you some ways to quickly show triangles are congruent using 3 different postulates. And we're going to start off with this one. I'm going to have to move your balloons out of the way if that's okay. So here's postulate 12. It says, if 3 sides of a triangle are congruent to 3 sides of another triangle, then those triangles are congruent. Now, the AKA that I would write for this one, they're talking about 3 sides being congruent. I would call this one AKA side, side, side theorem. Now, what they're really saying here, and I think I'll have to move these down just a teensy bit more, is that if you have 2 triangles and their corresponding sides, all 3 sides are congruent, then those 3 triangles are congruent. The next postulate, postulate 13, it says if 2 sides and an included angle are congruent to 2 sides and an included angle of another triangle, then those triangles are congruent. Now the key word that you may have missed is included angle. This is really important. So if you have 2 triangles and their sides are congruent, 2 sides, the included angle, and here they're talking about the angle in between these two sides right here. If those are congruent, then you can say those triangles are congruent. If I had to give this one an AKA, instead of side, 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 I would call this one side, angle, side. The very, very last theorem, now I'm going to move your cupcake. Uh-oh. I hope I can move your cupcake. Over here. There you go. Sorry. The very last one I want to talk to you about is postulate 14, which says if 2 angles and an included side, not an included angle, but an included side, are congruent to 2 angles and an included side of another triangle, then those 2 triangles are congruent. So in this case, they're saying if you have 2 triangles and you have 2 sets of angles that are congruent, if the included side, that's the side in between those 2 angles, is also congruent, then you can say that those 2 triangles are congruent. Instead of being side, angle, side, I would call this one angle, side, angle. So it's AKA is angle, side, angle. These 3 abbreviations represent the 3 ways you could prove triangles congruent.